himself. I'm not sure how humble you are. But John Bissell is our guest today. He's not only a Davis alum, but the founder of a company called Origin Materials. As always, I'll start with a couple questions at him, but we want to quickly get into your Q&A. So you're the ones asking questions. We're going to learn about what you want to talk about as opposed to what I do. So don't be timid and bashful about raising your hand. Make sure we get your questions answered. So let's give John a round of applause. Welcome here today. Okay, so John, I think the standard fare for these interviews is two questions we always want to know about. One, what in the world is it that your company does? And two, what's your background so that we can, follow that path and get there ourselves. So I'll let you answer either one of those questions, whatever order you want.
Yeah, so chemical engineer by training. I was, I sometimes say that chemical engineering is a fusion of physical chemistry and mechanical engineering, and people can sort of lie anywhere along that spectrum. I'm much closer to the physical chemistry side of chemical engineering than I am the mechanical engineering side. I don't know how to operate a lathe. I would be challenged probably. I'd probably lose a finger if I were operating in the student startup centers doing design stuff. But I'm pretty good when it comes to math and analytical capabilities and data processing. I know material science pretty well. My physics is pretty good. My chemistry is pretty good. So, but don't put me in a lab. So that's my background. I started a company, Origin Materials, as we described. We think of ourselves as a small Dow Chemical, or DuPont, which doesn't. I don't mean that in the sense of like, oh, it's a big chemical company that's a brand name. Dow and DuPont operate, or they characterize a very specific part of the chemical industry. So they're big chemical companies that just run big plants. They don't do technology development. They don't do application development. They make something somebody already knows how to make. And they use a process that's the same as everybody else. They're just really efficient at manufacturing and running really big plants. Dow and DuPont are good at that, but they also do their own technology development. So they invent entirely new materials with totally new processes and make totally new products that nobody's ever made before. And then they also run the big plants. So we see ourselves as that. We both do technology development and new product development. And we also intend to go build big plants and manufacture ourselves. To that effect, we developed a technology, a couple of them. One of them is at scale in Ontario, Canada, in a $150 million plant that's operating in a town called Sarnia, which I'm sure nobody's heard of. But it's sort of like just across the border from Detroit. So fly into Detroit, drive north until you hit the Canadian border, and there's Sarnia. It's a big chemical plant. If you're not used to chemical plants, when you drive from here to San Francisco, you pass at least what used to be the ConocoPhillips plant. I'm not sure whose it is now. I think it's still Conoco. But there's a big Conoco refinery there on the way down. It's very noticeable. You sort of go over the hill on the freeway, and on your right, if you're going towards San Francisco, there's this big refinery. That's a big version of the kind of stuff that we do. Our plants look like that, but they're smaller. We specifically develop technology around and products that are renewable. We have a sort of our big mission, our big rock, is we want to bring the right kinds of technology and product design to the chemical and materials industry to solve sustainability problems. That's sort of twofold. There's both beginning of life problems and end of life problems. We work on both. We think that they're important. You have to solve both. You can't solve one and then be ignorant about the other. They're two linked. And so our technology that we developed both uses renewable resources, so biomass. So ultimately, it's on a mathematical basis, it's sequestering carbon into the materials. And then we also make materials which are and design products which are easier to recycle on the other side. So that's our shtick. Awesome. We're a bunch of scientists and engineers, basically.
Okay, so that last comment, actually, question I want to follow up on. So you're talking about being a scientist, and then all of a sudden you're an entrepreneur. Mm-hmm. And I don't want to take for granted the transition of like working in the lab, student academic, to all of a sudden founding a company. Those are very different roles. How did you transition from the one to the other? Was that always the plan? Was it an accident? Like, maybe some detail how that happened.
Yeah, sure. So we were, you guys are undergrads, so I have to appropriately tune the kind of technical analogies I use. But so I think in retrospect, I was always focused on trying to work on things that mattered. I think a lot of people are. And I was looking for an opportunity to to sort of shift from working for somebody else doing that to working for myself doing that. And it turned out that opportunity was a competition that we participated in as an undergrad. So as a senior, I participated with a few other folks, one of whom is now my co-founder, in something called the EPA P3 program. I think it's still around, but it's the People, Prosperity, and the Planet is what the P3 stands for. It's basically it's a technology competition. It's like a big science fair. I think there were a couple hundred universities or teams that competed, and we won and got a $75,000 grant that we basically used to start the company. And then went out and raised capital and all the rest of it. But I think in retrospect, there was something that was going to bump me over into doing that. I didn't know that was what I was looking for, but now that I sort of know the way that the landscape of the world works, that was the way that was going to go. It just turned out to be that specifically.
Okay. Any advice you would give to someone who's, we've got a lot of engineers in the room, a lot of scientists, a lot of students looking to figure out what they want to do when they graduate?
Yeah.
Anything you wish you had known, like in that transition process, or is the iterating the point?
Iterating is part of the point, but I think one of the most important things about that is you really genuinely need to be interested in what you're going to go work on, because that interest is what gives you the tenacity required to be successful. So, and this is particularly coming from a scientist and engineer's perspective. If you're doing it, some people are genuinely just interested in the money, and that's okay. And if it's sort of money with impact, that's okay, whatever. But most people I find in our world are not. Most people are driven by their genuine curiosity and interest in a particular topic, in addition to their desire for impact. And I find that it's that interest that you want to be working on that thing. And so therefore, even if you are not successful immediately, you're working on what you wanted to be working on anyway. So you just keep working on it. And I think that's a really simple but really valuable North Star.
I like that. You got to be fired up about it.
Just got to be interested in it. That was kind of what we did. We basically picked our job by selecting something that we wanted to work on, and then figured out how do you make money on it.
Okay, well, so let's go back to Origin Materials. And you mentioned being a competitor, or similar to, maybe is the better way to put it, Dow, DuPont, and others. And so in trying to figure out what makes you different from them, you talked a lot about the idea of sustainability. Mm-hmm. And a couple questions there. How is that different than the way big companies like Dow and DuPont approach the world? Mm-hmm. And then maybe the flip side of that question, how have your customers reacted to this guiding North Star, this rock of yours?
Yeah, so I think it's really easy to mischaracterize a company like Dow, DuPont, or BASF, some of the sort of big integrated chemical companies. We try really hard not to do that, because we have to participate in that ecosystem with them as well. So I like your question about how are we differentiated, but it's quite nuanced. So, and it took us a long time to figure it out. So they generally won't take risk and try to go do something new that's more sustainable or better for human health or something like that. It's quite uncommon. And often lay people who are not involved in the industry go and say, well, look, they're just bad, they don't care. That's not how it works. What happens is these companies are aggregations of lots and lots of people that are all trying to be successful in their own career. And the ones that are really good at it and make decisions inside of these companies, and there are lots of them that are making decisions all the time, they have incentives. And those incentives are don't get fired and get promoted, basically, right? And if those aren't your incentives, then you never got into the place where you were making decisions at these companies anyway. So there's a selection criteria, there's a filter, right? So then you've got to think about, well, what does the career cycle look like? And this gets around to how are we different, I promise. So then you've got to think about what does their career cycle look like? Well, to get from the bottom to the top of a company like Dow, you basically have to get promoted about 8 times, give or take, over the course of your career. And then you'll be in the C-suite or in the executive suite, something like that. And that means that, and generally they want you to be there by the time you're in your 50s, They don't want a 70-year-old executive, they want a 50-something executive. So what that means is that you basically need to be getting, and you're going to get hung up in the beginning probably, so you need to get promoted about every 4 years, give or take. And to get promoted, because there's always somebody else gunning for the job above you, it's not just you, you have to basically not fuck up. So nothing big has to go wrong on your watch. Most of the time, nothing particularly has to go right, but things have to not go wrong. And what that means, okay, so wait, one more fact that's important for you guys to understand. New technology development in the chemical and materials world takes 15 to 20 years. Just, that's how it works, right? So that means that an R&D program that's going to do something new and different has to make it through something like 4, maybe 5, depending on exactly when the program started and when it ends, senior managers who have to continue to fund it. They have to say, I like this, I want to keep funding it. But you're going to go through maybe 2 or 3, and if you're really unlucky, 4 business cycles, which means there's 4 recessions of some sort that are going to go on during this project. And so at some point, there's going to be a guy who's responsible for continuing to fund this project, this R&D project, and it's going to be a recession. So the company's going to be going through cost cutting. And there's going to be a lot of pressure to say, let's cut programs that we don't have to do, especially ones that aren't making money. And he will not have been the guy who started the program, and the program's not going to finish under his watch. And so he gets to be a hero by cutting the program. And once that program's cut, it's gone forever. Those scientists go move on to something else. Nobody remembers it. Nobody wants to dig it up. Nobody wants to take the risk to do it again. And so consequently, these organizations that we as a species rely on to do fundamental technology development in the areas of materials are actually structured in such a way that it's almost impossible for new fundamental technology development to be done at these organizations. It basically can't happen because of the way that the incentives are structured for the individuals inside the company. And it doesn't matter if somebody at the top says, we're going to go do it anyway. It's irrelevant because the people inside the organization know that they're not going to get promoted if they let it fuck up on their watch, and they get to be a hero, maybe for the one time in their whole career, by cutting the program at a time when everybody wants things to be cut. And so because technology can't make it out of these companies, and it can't make it out into the production world, we basically haven't seen real fundamental materials development in the sort of bulk materials world. Bulk being like stuff that you touch and feel, right? Obviously it happens in semiconductors all the time. We haven't seen that happen in about 30 years. And so now we almost are, almost the generation of people who did do a bunch of that at these companies, they're almost all retired. So now not only are the incentives wrong to do it, but we don't have anybody left that knows how. And so we decided that we're not going to be that. We're going to go figure out how to do it. And we're going to learn from all the people that we possibly can. And we're going to set up our incentives in such a way that that doesn't happen. And that's what we're doing. That's how we're different. And so as a consequence, we can say we're going to go try to solve these problems. And we really do put our money where our mouth is in a way that the big companies basically, even if they really genuinely everybody wants to solve it, they can't.
It's almost like the innovation isn't in the technology, but in the process and the way the company's structured.
We didn't know that was how it was going to start out, but that's turned out to be the way it's true.
Well, let me ask one last question about that, and then we'll open it up to the audience. So get your questions ready. But for fear of asking questions that maybe is proprietary, like how in the world do you incentivize? Like why are you able to incentivize your employees differently than these companies are?
So a couple things. One is because we're using, I'd say, a more modern management practice.
Okay.
So equity is a much more modern mechanism to incentivize employees. Owners have always had it, but for employees and staff to get it.
So employees have ownership in the company?
Lots, right? So we take a very classic venture capital style startup approach to that. That makes a difference because now people can be rewarded for a project in the company being successful, not just via individual promotion to additional responsibility accountability. But that's not enough. We also have people, it's just a philosophy that we want people to follow projects across the entire life cycle of the project. So people are, there are probably ways we could do this more formally, but people are kind of signing up to see something through to the end. And that drives the learning cycle. The next is we select for people who care more about the mission than they do about sort of traditional promotions. Part of that is because we're small enough that we can do that. if we had to have 60,000 employees, I don't know if you can find enough people to fill all those gaps to do that. So this is sort of a classic counter-positioning competitive advantage. We're smaller, we're different, we're building from a different spot, and so therefore we can build a different kind of company in a way that Dow couldn't choose to change to, even if they wanted to, without sort of dismantling everything that makes them successful right now.
Right, interesting. Classic disruptive innovation here. Okay, let's open it up to you. You've heard me do enough talking here. What questions do you all have for John? Yeah, go ahead.
You talked a lot about interest and really loving what you do. What would you say to an engineer who doesn't have that path or that idea that kind of wakes them up in the morning?
So one of the interesting things is, and there's been pushback in the startup community broadly against this, but the idea is often not the key thing. In fact, I'd say it's usually not the key thing. Now, you have to temper that a little bit because, especially in the world of non-computer science engineering, you have limits on how many times you can sort of iterate because there's development time and there's real development cost. Not that there's no development cost in CS, but it's characteristically different. And so you don't get unlimited lives, even if you spend them fast. And so you have to be careful about the idea. But the idea you start with isn't the important thing. I think the problem focus is probably the right starting point, but then you sort of iterate on problem, and then you may find, because you're following interest, that, well, the way that I want to solve that problem maybe turns out not to be the right way to solve that problem, but I'm now interested in the thing that I'm working on, the solution. What other things could that solution solve? That may make you fall in love with a slightly different problem, but with that solution. Then you keep iterating sort of problem, solution, what's the thing, but you're following interest, right? That's why I think interest is the key dimension to optimize on. But you don't have to have an idea that starts out. You could easily fall in love with a problem. I also think, I was talking to somebody about this on Wednesday. As an engineer, you guys may not really have experienced this yet, depending on how long you've been studying engineering, but you kind of reprogram your whole brain to think like an engineer. And people choose different things to use as their lens to see the world through. So controls people tend to think of the whole world as a control system. Thermodynamics people tend to think of the whole world thermodynamically, right? Some people think about it through something like a free body diagram, right? And you just start to view the whole world through free body diagrams, effectively, or dynamics or kinematics or whatever your thing is. Stability is another one that people often will use as like a universal codex for the world. And you have to kind of do that in entrepreneurship too. So you will rewire almost everything you think about in this new way of seeing the world. And that's not to say there's one entrepreneurial way of seeing the world, but if you think about problems as like, I want to, I'll pick one that's sort of not that interesting, but is useful for the example, like energy efficiency, right? You might start looking at every single thing all the time as an energy optimization problem, right? How can I optimize the energy utilization here better? And over the course of a year of thinking about that as your interesting problem, you've now changed the way you see almost everything in the whole world. And you're looking for something that is now interesting enough in that context to work on. It's not like you sit down and say, what's the thing I've always loved since I was 2, right? I mean, for me, the answer would be paleontology, but that's not why I want to, that's not what I want to spend my life doing right now. Does that make sense?
Yeah, thank you.
Good question. Go ahead. Go here. Yeah.
When you were initially partnering, you started the company about 2009, 8?
8, I think, nominally.
You partnered with Mitsubishi Gas. How did you sell yourself to be able to receive funding from them?
We didn't work with them until much later.
Okay.
Yeah,
So later on.
Yeah, that was probably, that might have been 2019 that we were working with Mitsubishi Gas Chemical, and 2008 when we started the company.
Let me rephrase it then.
Yeah, sure.
When you initially started,
Yep.
how did you sell yourself to be able to get funding from different companies to start off?
So there are tricks in there. Everybody has a bit of a different style, and it depends on the specifics of what you're bringing to it. I think, speaking to you guys at your current level of career development, let's call it, or stage of career development, I would say your earnestness and your ability to focus on whatever it is that you're working on, your problem, right? When you end up talking to other parties, that shows through. And that's probably one of the most effective ways to sell yourself, is by genuinely just being interested in the problem you're trying to solve. And by authentically being just interested in that and not thinking about selling yourself in the beginning, that's almost the best. In fact, sort of microcosm of that would be when we interview fresh grads, right? If somebody absolutely attaches themselves to the problem that you're working on, or that we often do like, here's a system, tell me about the system, or solve this element of the system for me in an interview for a technical person. If they like can't let go of that problem and they just keep grinding on it, that's one of the best ways they can sell themselves. It's like, just don't fucking let up ever on whatever the thing you're trying to solve is. That's way better than everything else. I don't care about everything else. Do that. Does that make sense?
This is sort of a specific question, but I saw that Europe over the summer passed a regulation that requires bottle caps to remain tethered. Yeah. And then you also closed a big deal with, I think, a Swiss manufacturer for those tethered caps. Mm-hmm. I was wondering, sometimes EU regulations like that tend to have an effect on American products too. Mm-hmm. Like, for example, the new iPhone having a USB-C rather than Lightning. Mm-hmm. Do you anticipate seeing tethered caps coming over to the US in the future, I guess?
Yeah, there's some that are already here. You're right, that is a very specific question, but it's kind of interesting from a market dynamics perspective. I think contagion is an interesting way to think about markets, especially with consumers. Although it's true outside of consumer, like B2B markets, that's true too. But once something exists, then it can spread. And so California usually it happens that California is the first one to do it. We just are sort of desensitized to that because we live in California. But usually California is the first in the world to do something, and then it spreads from California everywhere else. And you can sort of look at some of the parameters for like how likely is the contagion to spread, and you can look at like what's the total market size that the contagion starts in. Is that large enough to change the supply chains for the product suppliers? If it is, then they're probably going to start switching things over, which means that it may be more efficient for them to just flip over and add in additional functionality. That's how the catalytic converter worked, actually. The catalytic converter was introduced largely because car manufacturers said, well, if I have to put this on to supply this particular market, I might as well just put it on everything. And then the regulations look at it and they say, well, if that's possible, everybody told me we couldn't do that, but you guys just did it over there, so it must be possible, so therefore let's apply regulations across it, right? Those are sort of typical market dynamic effects. And yeah, so tethers already exist in the US and they'll probably become more prevalent.
There's a good reason to be near Sacramento, regulate all these things, California.
Yeah.
Go hire a lobbyist or something. Yeah, go ahead.
Origin's publicly traded as a company, right? So do you notice any changes? Because it was around like 2021 when it went public. Do you notice any changes, like as a founder before as opposed to after?
Certainly. A lot of people dislike the public markets because they feel like they are suddenly accountable in a practical way to parties who don't have enough expertise. So they basically say, well, I can't make the decisions I want anymore without there being negative ramifications from market price or something like that, right? But I think that was mitigated for me a little bit for three reasons. One, I tend to want to bring my stakeholders along anyway. And I view that as just, there's something I can learn from everybody. And so even if I disagree with them, I want to understand why they disagree with me so strongly so that I can learn what I can from them. So I was putting energy, even as a private company, into a lot of people that were stakeholders for the organization in the same way that retail investors, for example, are stakeholders now to our organization. And so it doesn't feel like a major change in the amount of energy I put into sort of stakeholders that don't know what the hell they're talking about, which is sort of how people view retail investors frequently. Two, people also don't they get fearful of stock price change and greedy on the other side of wanting it to go up, and so they want to control that as much as they can. And I'm not going to say that I don't care, but I think I'm more insulated from that just because of my personality. I'm used to doing a bunch of stuff that people don't agree with, don't like, and just wearing whatever the consequences of those things are. My parents said that made me very difficult to parent. But it's been like that for me for a long time. And so that didn't matter that much to me. It matters, but it's not as dramatic. And then the third component is that because of the kind of company we are, people don't feel like the management team is interchangeable. So we're sort of strange. And as a consequence, I'm not as vulnerable to investor attack or hostile takeover, something like that, even though we're small, as a lot of other companies that might be more easily understood by an activist investor. Most activist investors, I would guess, they usually don't tell you they're coming if they show up until later, but they probably look at us and go like, fuck, I don't know how to operate that business. Like, you guys do whatever you want. Which has pros and cons, right? Our stock price is probably lower as a consequence of that, but also it means that that I, it's still my company.
Awesome. Other questions? What else we got? Yeah, go ahead.
A lot in Posse discuss about the broad customer segment versus narrow when you focus. Did you have a certain customer segment you focused on initially, or no?
No, we fucked that up. So we started out by, well, I'm simplifying a little bit, but we started out by going after a market for a particular chemical called paraxylene, which is an enormous market. It's a commodity market. So we had to do zero product development, mostly. And the thought was, let's not take both product and process risk. Let's take just process risk. So process risk is like, do I know how to make it? Product risk is, does somebody want to buy it? And so we chose to we knew we were going to have to take process risk, so we said, let's just take process risk and not take any product risk. And that was challenging for a variety of reasons. One, because if you're making the same product, then it's hard to differentiate, which means it's hard to get differentiated pricing. And so therefore, you can't have your pricing respond to your production cost in the beginning. Well, period. But especially in the beginning, that matters. What you want to be able to do is make something that nobody else is making. And to some small, narrow part of the market, that's valuable enough that they'll pay whatever your early costs are, even if someday you'll be able to get down to lower costs. We had a lot of trouble doing that in the beginning. It was really, really hard to get people to pay more for the product that we were making, because at the end of the day, it was the same thing that they could buy from somewhere else. It just had a different carbon footprint. So yeah, we didn't take any product risk, but we converted the product risk into pricing risk, which basically was margin risk and economics risk, which was process risk. So we basically like doubled, tripled, or quadrupled our process risk in the beginning without really knowing that was what we were doing. And so we, and what was challenging about that too is it's like crack. You get so attached to the size and scale of that market that it becomes very difficult to convince yourself to differentiate and take on product risk. We did end up doing that, but it was very hard. And so that was really tricky. We went after a really, really big market to begin with, and that was, it almost killed us. What we should have done is gone after a very narrow market that was adjacent, using our sort of technology that was adjacent to some very large markets, ideally a series of sort of stepping stone markets that you can get up to over time.
Could you give me an example, like what would you, like when you're saying like a narrow market?
Yeah, sure. So like, let's use clothing as an example, okay? So we're all wearing shirts, right? Generally, I'm sure, I don't know. I'll look around and see if there's nobody wearing a dress. Okay, fine. But the shirt market is from a functionality perspective, is mostly commoditized. But of course, it's not really, right? They've developed differentiation inside of the shirt market. But I can go find, if I want like a merino wool navy t-shirt, which is what I'm wearing, I can go find that at a lot of different brands and different price points and slightly different sort of finish levels, and they have a little bit of different characteristic, but it's all kind of the same thing. What I want to do is start with a really high-end brand that's high value and high price and high margin. Maybe it's like, I don't know, Nerona or Gucci would be what people used to use as the example for that kind of thing, right? So I would pick that first. And I might only have to make like 1,000 shirts because that's all they ever sell. That's narrow. There's almost nobody that buys them, but when they buy them, they spend a lot of money. I don't want to start at Walmart merino shirts. Maybe that's the reason I got into the technology in the first place, is I ultimately want to get there, but don't start there, or Costco. That's a bad idea. Because one, you're going to have to invest huge amounts of capital and resources into scaling up enough to even make a difference for them. Two, their consumers don't, the whole point is they don't want to pay more. That's why they're shopping at Walmart or Costco. And so consequently, you have to be dialed on your cost side in order to supply them in the first place, right? Does that make sense? Yep.
Yeah, please.
You talk about the sense of like loyalty, which is like your defining edge compared to the other kind of manufacturers. How do you create that sense of loyalty to the mission or the company?
Some of it is, are you guys familiar with the founder effect? So the founder effect is the attributes that you start something with, and it's not just companies. It's a much more generalized effect than just in companies. How you start it has a long-range effect on how it will be much later. And that's surprising because you would say, why does the behavior of the first person who starts something change a 50,000 person organization, right? Like you just hired 49,999 of the people. Why is that? Why is there some sort of propagation of the characteristics of that first person? Well, it's I like to think of that as like crystallization, or self-organization is a nice way to think about that. In that, if I start, there can be multiple crystal polymorphs for the same compound. Which polymorph I start with, I only have to start with like one tiny little crystallite, maybe angstroms across, and I will crystallize out all of that polymorph and none of the other one, right? Because molecule by molecule, they're assembling around that first polymorph, and that's how you're creating the crystal. Same thing happens in organizations, right? So if I hire people in the beginning who are loyal to the mission, right, and think about it differently, they also are going to go filter to select for people who are loyal to the mission and think about it differently, right? And then you're going to choose compensation schemes and incentive schemes which are consistent with that loyalty to the mission, right? And then those incentive schemes are also going to continue reinforcing your attraction to people who are loyal to the mission, right? And so it just like, it all wraps around it. And that's why it's so hard if I have a 50,000 person company like Dow Chemical and I say, I want to go change it. Well, I mean, maybe there's only 1,000 of those 60,000 people that are even that would have chosen to work for the company that was mission oriented instead of sort of traditional promotion track, or however you want to describe that, right? And so, sure, I could like try to evangelize it to 59,000 people, but I'm probably only going to be successful at, I don't know, a 50% rate if I'm lucky. So then I've got 30,000 people that need to churn out of the organization, and I've got to go find 30,000 people to replace them to do their jobs that I've now applied a new selection filter for. It's just impossible, right? It's not doable. And so that's part of the deal. You just start. You pick.
We'll go 1, 2, 3.
Okay. So you talked about how loyalty and that you really value that, and you want to hire people that value the mission. But while I'm doing my own projects or like my own startups, people kept telling me, don't get too attached to your projects or don't get too attached to your product. While I myself might agree with your point more, but like, why are they telling me that?
Those are two different phases. So, and by the way, loyalty, I just want to be careful because we're talking about loyalty in the abstract, and I keep saying loyalty to the mission. Loyalty to me is not, I mean, sure, a certain amount of loyalty to the company is important, but loyalty to me is not important in my view. I mean, there are lots of people who have that, but inside of my company, I mean, frankly, they should tell me to fuck off if they think I'm wrong, right? And I want them to do that because they want to complete the mission. If they think I'm wrong, it's more important, it should be more important to them that we're gonna do the right things than to do what I want, right? So I think that's just an important distinction there. But you're talking about two different phases, right? So one is I'm looking for the thing to do. So sometimes I think it's useful to take companies and use analogies to things that are really simple. So like, let's say mining, right? And let's take the most reduced version of mining, which is literally I need to find a spot to dig a hole, and then I need to dig the hole and look for the thing I'm looking for, right? So there's one process that you're going to use to find the spot you want to dig. There's a completely different thought process behind getting 100 people to be digging in that spot. You don't want 100 people that are supposed to be digging the hole in the spot you've already decided, however you decided it, that was where you want to dig. It would be bad if every single one of them was constantly wandering off to go pick something new to dig. You know, like they're digging all over the place, nobody cares, you know, that's not right, right? They need to be attached to the mission of digging. But you shouldn't be, I mean, it would be odd for you to say, you know, I fell in love with that rock. That's the right rock for me to dig in. I'm not going to think about all the other ones. You want to evaluate all these things and then ultimately decide that that's the spot you want to go dig, right? Does that make sense? These are different phases. You shouldn't, what happens in one phase needs to be, it needs to sort of talk to and interface in a logical way with what happens in the next phase, but it shouldn't be the same. That's why they're different phases. The phase defines the difference in behavior.
So just keep trying to find that right rock and then just go.
Yeah, what's the thing you want to do? What's your thing you're interested in? I mean, if your drive is profit and money or something like that, then that might be different than if it's technical interest or if it's, which is what I think is often good for engineers and scientists to be focused on, or it could be you know, something else. Could be lifestyle, right? Not every company ends up being some sort of gigantic behemoth. Sometimes you're just doing it because I want to generate a nice, comfortable lifestyle for myself, and I think it's an interesting problem, you know. But prosecuting the opportunity and selecting the opportunity are two different things.
Go ahead.
So you mentioned that you got the $75K grant. I was wondering where you delegate the money towards, or where the money goes.
Well, $75,000 in the world of, well, in the world generally, but especially in the world of chemicals is basically nothing. So I think it bought us like lab glassware and then it was gone. Like, I mean, I literally, beakers go for, like the glass beakers you guys use in Chem Lab, I haven't looked recently, but I think they go for a couple $100 each. Typically, maybe 100, depends on how big they are, right? And if you look at, but stuff like that, it's stupid expensive. And so it just, gone. Plus there's like overhead that gets taken, and then there's this, and there's that, and it's all.
So then how did you like fundraise or?
We had to, I went and raised a bunch of money from local investors in Sacramento, and then figured out how to raise capital from sort of more formal investors like venture capitalists on Sand Hill Road and all that kind of stuff. And then I raised money from corporates. We were talking about Mitsubishi Gas Chemical, which is not one that I particularly raised money from specifically, but we had a partnership with them. But companies like that, you know, Nestle, Danone, and Pepsi ended up being customers and also investors. And then ultimately took the company public, right, to raise additional capital. But yeah, so the fundraising journey is different for every company, but for us, that was sort of the deal.
I wanted to ask you your read on just the larger landscape. The National Academy came out with a report last year talking about that the chemical economy you mentioned, you talked about Dow Chemical and kind of as a slow to change organization. And I wanted to ask specifically, what kind of technologies do you see as disrupting within the chemical economy? So if you could just speak to what is the big picture?
Yeah. So by the way, I don't think that companies like Dow are necessarily slow to change in general. So they're slow to change their core process technologies and materials, right? Which is different. They can be very fast to change. In fact, the U.S. economy broadly it's in the world of energy and chemicals and materials. It's useful to think about the U.S. economy as being the fastest economy in the world at redeploying capital. And Dow is definitely part of that. So when natural gas got cheap because of fracking, the US does not have the best fracking resources, nor does it have the most. We are just way faster at deploying capital to go get the gas than everybody else in the world. Nobody else is even in the same ballpark. So Dow, for example, basically started switching over the entirety of all their operations to being natural gas fed instead of oil fed in like insane times. It was something like $50 billion of revenue per year switched from being oil to natural gas in like 2 years. It was crazy fast. So it's definitely not true that these guys are slow at everything. They're slow at very specific things that we see the ramifications of. In terms of your comments about, or your question about technology, I think if you look at the big picture, there are a couple different thresholds. So first, we should be using renewable resources. There are a variety of sort of grades of quality of renewable resources. At one set, you would say CO2 is a great resource that we should be using to build things. The challenge is that it's energetically extremely stable, so you've got to lift it way back up to be able to go do something interesting with it. And energy is basically too expensive right now to do that effectively. As energy gets cheaper, and there are a lot of ways that could happen, like effective nuclear power and broad-scale nuclear power could do it, renewables can do it, but as energy gets cheaper, particularly electricity, then CO2 will probably become the most interesting feedstock for a lot of these things, because the energy is also going to drop the cost of acquiring the CO2 in the first place. But until energy gets cheap, you really have to be, in my view, using renewable resources that have an impact on CO2 on a net basis, but which may not be CO2 directly. So direct air capture, in my view, is still too expensive and to be used broadly. And energy is too expensive to convert CO2 into chemicals broadly. And so that's why we use biomass. We use biomass because sometimes the way that I describe plants and trees is imagine that you could have a solar-powered direct air capture unit that not only repairs itself, but reproduces and covers as much ground as it can without additional maintenance. That's effectively what photosynthetic organisms do. And so if you can use those photosynthetic organisms to do direct air capture and then subsequently convert those into useful materials, then that's a good way to capture the carbon that they captured out of the atmosphere. There are definitely ways to do that wrong. There are ways to do that right? But I think that, so I think that's really interesting. That's why we do it. As energy gets cheaper, then I think it's going to shift towards a more sort of direct air capture of CO2 and then direct electrochemical probably conversion of CO2 into other products. But I don't know how far out that is. Could be 20 or 30 years before energy gets cheap enough to do that. Does that answer your question?
And maybe you could talk a little bit about, like last year at the ACS meeting, the topic was data and how AI is, and the Nobel Prize in Chemistry, right? It has to do with
a couple days ago.
Predicting protein structure. So where do you see that? And are we close to a breakthrough in chemical technologies?
So I don't think so on the production side. And we follow this pretty carefully. The reason I think it I think what might happen is it might shorten the, that 15 to 20 years I was talking about to do new technology process development. That might get shortened. It's probably going to get shortened in some of the later stages first, I think. So if we can get people to give data on capital project execution, so like going and building big plants, which takes years, and doing cost estimation there and engineering sort of work breakdowns and all that kind of stuff, if we can get people to roll their data globally into that and give that access to AIs, then that seems like that might be a way where we can go faster, and you can shave years off that way. I can see how it might help on the front end too when you're trying to do like catalyst discovery or process development. Maybe it drops all those by 2 or 3, and you get to the point that you can do a lot of this stuff in silico instead, and maybe you get to like 10 years or 7 years or something like that for the technology development process, but it's still long. I think where it's going to be incredibly helpful is in the what we call the application side. So not making the material, but what the hell do you do with the material, right? Do you make bottles and caps, which ordinarily, it's about 30 years between the development of PET and the use of PET to make bottles. And that's because there's some really unusual physical characteristics for PET that enables them to be really efficient at making a bottle. You could argue about whether that was a good thing or a bad thing, but the case is it took 30 years for people to figure out that that was the thing to do with PET. Similarly with polyester fiber, right? We get better and better at making polyester fibers for clothing instead of using shitloads of water to grow cotton in the middle of the desert to make clothing. But it took people a long time to figure that out. And so I can definitely see a case for AI to get way better, AI and data. But I think the data is not as useful without the AI. And so for AI to get, to make it way easier to make new products out of both existing materials and identifying what things would be interesting to make out of a new material. So I think it's much more on the application side where the AI is going to have an impact than it is on the fundamental process development and material side. I'll probably eat my words in 10 years, but.
We won't ask you to be perfect on future predictions. So John, we got about 60 seconds left. We like to ask all of our founders, it's kind of a parting question, but you've launched the company, you made it happen, you created something out of nothing. What does it mean to you to be able to tell the world that you've done that thing?
It's kind of funny. Like, I think as, I'll make an analogy to school. When you're a 7th grader, or a 5th grader, it sort of feels crazy to think that someday you would have graduated from high school. And similarly, as a freshman in high school, the idea that someday you're going to have a degree in, electrical engineering or something like that from college feels sort of wild and far off and abstract. And that's kind of how it feels, But then after you've done it, of course, you're like, sure, I'm one of many people who did that. It doesn't feel that much different. That's kind of how it feels to me.
I like that. Awesome. Let's give John a round of applause. Thank you.
Thanks.